Welcome back to our R learning session. Today, I'll be going through some basic functions in R. Let's start by clearing the memory of the computer. How do you do that? We can do that by using remove function. Here we go. Rm list equal to ls. Once we run this, it's going to clear all the objects in the memory. Now, we need to import some data into our memory. How we can do that? Let me show you. We need to first invoke read function, and it's a CSV file. It's a CSV file, and for that I will be calling a file name called tb country CSV, and false. Let's run this and see what we get. We see that it has imported a file name with the two columns, v1 and v2. Does that make sense? Let's check what the file says here. Let's open the file and see what's inside it. It's not clear what's inside it. But anyways, we see that this file has many data points, around 5,000 rows, and each row has a 10 variables in it. There are v1 through v5, v10 exactly. There are v10 variables in it, or more than that, 47 variables. Each data point has 47 variables in it. It's a big file. What happened here is that if you look at the column 1, it doesn't actually look like a data point. It looks like a column name. It happened because we put a header as false. Let's do it again by changing this to true and see what we get. And I will comment it out. I'll comment this out so that it won't run next time. Code, how do we comment here? Comment, Control Shift G. This has been commented. Let's change this to true and run this again. Now we have a data. Now it has read a file. So next step is to actually save this in a object. Let's name this as a sample CSV. and run this again. Let's see what's inside this file. We see that in this object we have, which has been imported into our memory, we have all the data points and a column name for each of the data points, variables inside the data point. In each data point is each line, and for each line we have many variables in it, and each variable has a column name associated with that. That was not the case when we said header was false. Moving on, let's try to play with some other kind of files which are not CSV. Let's play with new file called and use a new command called read table, and this command is used to read a file which are non-CSV. And let me type the file name here. Let's see, CSV, but this is not a file, CSV file. This has to be something like a txt file. And the separator in this file is a tab /t. Header, let's do false and see what we get. Sample tsv, and let's name this file as sample tsv in a memory with headerless. Let's do headerless for this one. Let's run this again. Let's look at the file here, and we see that this file has been imported, which is a tab separated file, and this has been imported in the memory. As we have seen earlier, the first data point is column name, which is not the case. We have to fix this by commenting this out. And let's copy this and set this as true. Let's run this again. This time it's going to be header, not headerless. Pardon me. Let's run this again. Can we guess what we will see now? Let me show you. We see a file that has column name and data points which are appropriately formatted. Earlier we didn't have any column name. Now we have column name because we set header as true. Separator can be many separator. We have to specify what separator do we have. We can use the same command using comma if we have a comma separated value. It's a multi-purpose command. This one is just we read a comma separated values, but this is a multi-purpose command which you can use read many kinds of files. Let me quickly summarize what we discussed today. We talked about using remove rm function to clear our memory. We talked about read CSV, which reads the CSV file. It is a special purpose command that just to read a CSV file. And read table, which is a multi-purpose command that can read any type of file provided that we specified a separator. And we also talked about setting header is true or false. Thank you so much. I will see you in our next learning session. Welcome back to our learning session. Today, we'll be talking about accessing data. In last lecture, we talked about importing data. We'll be using same data objects to access this time. So let's begin. First of all, we'll use summary function to inspect the data. What does summary function do? Can you guess? Summary function helps you summarize the data by producing the statistical values for numeric columns. Let me show you. Wherever there's a numeric column, numeric values, it produces some statistics for those columns. Now we have inspected those statistics. We'll comment it out so that we can try different command. Let me comment this out. Secondly, let's try structure command or structure function that helps to identify the structure of a table or data frame. We want to see what does the structure of the data frame look like. Let's run this. It says there are quite a few columns here. There are 47 variables or 47 columns, and there are around 5,000 rows in this data frame. Now let me copy some column I'll be inspecting, or I'll be doing some exploratory data analysis on, so that I have it handy, and comment it out so that I don't want to run this column. It doesn't make any sense. Now I have that. Let me comment this out as well. Now let's inspect how many rows this data frame has. We already know it's 5,120, but what if you want to just give a single number? What if I want to get just single number instead of all this information in the screen? There's a command for that. Can you guess what it is? Let me show you. nrow sample CSV file. This will give the number of rows in a given data frame. Once I have it, let me comment it out as well to keep the screen clean. Next one is max. How do we get the maximum value for a given column? Can you tell me how? Yes, we use max function for that. Let me use max function. What would be the input for this function? It will be the column name we are interested in. Sample CSV and estimated to population number. That's what I'm interested in. Let me run this. This is the number that's the maximum for this particular column. That's interesting. It's such a huge number, isn't it? Now, let me find what's the minimum for this particular column. Let me copy and paste this inside a brackets. 1,129. It's a small number. these two numbers are different in order of 100,000. That's amazing. Let me comment them out because we don't need them anymore. How do you find the unique values for a given column? Can you guess? Let me show you how to do it. For that, we use the unique function. Unique function is a function we use, and we use a command that's inside. We use a column name that this function intakes to compute the unique values of a given column. These are the unique values for this given column. These values are not sorted in any ways. We want to sort them so that it's easier to look at. Let me sort them using sort command. And let me comment this out as well because I don't need this anymore. Let me run it. There you go. We have these values in sorted order. Nicely sorted. This is such a huge, there are so many values on a screen. Can you guess how can we see how many values we have in this vector? Let me show you. We use the length function for that to size the vector, and once we have that, I'll just input the vector producing function inside the function length. And let me comment out because we don't need anymore. And let's see what we get after we run this. 5114. That many unique values this column have. Interesting, isn't it? Now, once we have this, do you know how we can filter for a certain condition? How we can filter a data frame for a certain condition? Can you tell me how to do that? We can do that using which function. This is one of the most useful function in R. Which function? Which, and I can use the same column name we have been using in prior commands to filter for something. We can filter for the lowest value we have in this column is 1129. And let me comment this out so that it doesn't get crowded. And when we run this thing, unexpected error. We have an extra bracket here. I'm going to remove this and run this again. And 4540. What is this? This is the row number of the data frame. That means if I go to this row, I can find the row that satisfies this condition. Now, suddenly I'm interested to see what is the size of this output. How do I do that? You're right. I can still use the length function to do this. Let me show you. I use the length function here to size this vector. After we have done this thing, let me comment this out so that we can look at the other functions that may be useful for accessing the data. One particularly useful function are is matrix. It identifies, it inputs an object and identifies whether the data object is matrix. And it goes like this: matrix sample CSV. When I run this, can you tell me will it return true or false? Let me show you. It returns false. Why is that? It returns false because sample CSV is created by read.csv file, which always returns a data frame. Now let me see whether this is my saying is true or false. Let me run other command that says data frame. Is it a data frame? And run the sample CSV file again. And what happens? True. It seems that sample CSV file is actually a data frame. That's the end of our learning session today. Let me briefly quickly review what we discussed. Today we talked about summary function that summarizes numeric values and produces statistics such as mean, median, max. str function outputs the structure of the given data object. nrow function produces how many rows the given data object has. Max function shows you what's the maximum value for a given data column. Min shows you what's the minimum value for given data column. Unique shows you what are unique values for a given data column. Sort shows you the sorted values for given data column. Length shows you what's the size of the given vector, which shows you what are the row number for row of a row, what are rows number or what are rows number of a given data frame that satisfies the particular condition. And finally, is matrix and is data checks whether particular data object is matrix or data frame. That's all for today. I will see you in next learning session. Thank you so much. Welcome back to our learning session. Today we'll be continuing tutorial's basic function. Today we'll focus on manipulating data in R. Remember last time we talked about a sample CSV and we were checking if the sample CSV is a matrix or is a data frame. And when we did that, the matrix came out to be false and data frame came out to be true. So we'll continue that. Let's load again the sample CSV file, but this time let's load it as a data frame. We'll name it sample CSV, and as matrix sample CSV. Now let's check whether the sample CSV is a data frame or matrix. What do you think? Will it return true or false? Let's see. Let me run this. What is happening here? Not sure what is happening here. Let me check. Run the selected lines. You should run this. Let me check how to run this. Zero len variable name. What's happening? I suspect it's happening because we need to run all these processes again, and then only it'll run. Let's run from the beginning and let's see if it'll work. I made a mistake here. And the mistake is that why do you have this here? It should not be here. Now it will run. It says is matrix true for a sample CSV, and that's exactly what we wanted. Now let's create a matrix and let's name it as A. Let's create a matrix now. Matrix A has been created. And let's see what's inside this matrix. It's a 3-column matrix, and there's all ones in it. So what's saying is that 1, 2, 3, what does it mean? Data I want to populate is 1, number of columns is 2, and number of rows is 2. RC, number of rows is 2, number of columns is 3. I created 2 by 3 matrix, populate all by 1. That's what it means. 1, 2, 3. There's a meaning in that as well. Now let's transpose this matrix and let's see what we get. What do you think we'll get if we run this? Let's see. Earlier we have two rows and 3 columns. Now we have 3 rows and 2 columns. So this exactly has a transpose. Now let's try a run on a test with is matrix A. Is matrix, and what do you think we'll get? Let's see. Let's see what we get here. True. This is a matrix. Now, can I use another function as a data frame on matrix? Let us try. There you go. We have a matrix with the 2 rows and 3 columns, and it's in a data frame format. And this is in matrix format. What's the difference between matrix and data frame? You will see that if in matrix the rows are 1 comma and 2 comma, and columns have comma 1, comma 2, and comma 3. But in data frame, it says v1, v2, and v3, and there's no labels for rows. That's the difference between matrix and data frame. Next step, can we do delete, add, and column to a matrix? Yes, we can. Let's see how. Delete, add a row, column to a given matrix. A. Let's see what we get when we type this A here. So we have a matrix which has 2 rows and 3 columns, and we want to delete a row from this matrix. How do you do that? Let me show you. A is a new matrix defined, or is a resulting matrix defined by deletion of the first row. And how do you do that? We do that by typing 1 and typing 1 and putting minus in front of it. It's a row and comma. When you, the notation, this is how notation goes. There are 2 places where you can put numbers, before comma and after comma. Before comma is for row and after comma is for column. Before comma, when you put a number, it signifies the particular row number. And if you put minus in front, that means you are deleting that particular row. And if it's empty, that means it's all the columns. Now let's see what we get, shall we? Let me run this. We have a resulting matrix that has only one row. It's 1 1 1. Now, can we add a row to the matrix? Let's find out. Let's define a new matrix, redefine the matrix A, and let's do row binding. And it takes 3 inputs, 2 inputs: A, the original matrix, and C as a new input values for a particular matrix, 2 2 2. And when we run this, do you think we'll be able to get attach a row to the given matrix? Let's find out. Here we have a new matrix where there are 2 rows, 1 1 1 and 2 2 2 for a given matrix. Interestingly, it doesn't have 1 2 and 1 and 2 prepended in front of rows. Now let's do column bind for the same matrix and let's see what we get. C bind, a column bind, A, C, 2, 3. We're adding column to this matrix, and let's run this and see what we get. Here we go. We have a 4th column, that is 2 3 for the first 2 rows. In this way, we're able to manipulate a matrix matrix using different commands such as rbind, cbind, and we can even delete the particular row from a matrix. We can use functions such as matrix and as data frame to convert matrix to data frame and data frame to matrix. They are very useful commands that we'll be using throughout our lecture to work with matrix and data frames. That's all for today. Let me briefly summarize what we discussed today. We talked about manipulating data. We use as matrix and is matrix to work with the matrix and data frames, and we work with the matrix to delete rows from the matrix, adding a rows to the matrix, and adding a column to the matrix. Thank you so much. I will see you in the next learning session.